Twinkle, twinkle, little star, why do these stars twinkle at us? And planets don't twinkle. Why don't planets twinkle? The stars only twinkle due to our atmosphere. And we know this because if we look at these stars from outside our atmosphere, like the astronauts on the space station, they don't see the stars twinkling at all. So let's explore how this atmosphere makes all these stars twinkle at us. So let's say we're standing over here on Earth looking at this star. Now, due to our atmosphere, there are two things that are going to happen. First, as the light enters from space into the atmosphere, it's going to bend a little bit. And this happens because the light decreases its speed. It slows down as it enters into our atmosphere just a little bit. And as a result, it refracts, it bends. And because of this bending, when we look at this star, it appears to us as if these rays of light are coming from somewhere higher in the sky. And so when we look at the star, we don't see it over here, we're going to see it a little bit higher. So the first effect of the atmosphere is that it shifts the position of the star. This effect is greater when the stars are closer to the horizon because the rays of light pass through a larger part of the atmosphere. But the twinkling effect is not caused due to this. So what causes the twinkling effect? Well, if we were to zoom in and look at the light as it traveled through our atmosphere, then we would see that as it travels down towards the Earth's surface, light doesn't travel in a straight line, but it continuously keeps bending. This happens because the light is passing through several layers of our atmosphere, and as it passes from one layer to another, there is changes in the temperature, there is changes in the density, there's pollution and dust particles, and because of this, the light continuously keeps changing its speed as it moves from one layer to another. And as a result, light continuously keeps refracting or bending as it moves towards us. And more importantly, the temperature and the density of the air, it's continuously fluctuating even with time. It changes with time continuously. And as a result, the path taken by the light also slightly keeps changing. So the bending is not the same. The very next moment, it might take a little different path. And this causes the stars to twinkle. But why exactly? What happens if the light bends? Well, let's zoom in a little further. So let's say this is our eyes as we are looking at that star. And currently, let's say about 5 rays of light are reaching our eyes. And because of this, we are seeing right now the star to be as bright as we can see over here. But because the atmospheric conditions are continuously changing with time, maybe the very next moment, the path taken by this light changes a little bit, and as a result, let's say that one of these rays slightly bend away, missing our eyes. So maybe the very next moment, instead of 5, only 4 rays reach our eyes. Now because of 4 rays reaching our eyes, the star is going to look a little bit dim. Maybe the next moment only 2 rays reach our eyes. So now the star is going to look even more dim. And so you see, due to the continuous changes in the atmosphere, fluctuations in the temperature and density and all the other things, because the light is continuously changing its path, the rays that reach our eyes continuously changes, and as a result, the brightness of the star keeps changing. And this is what causes the twinkling effect of the stars. So the next question is, why don't planets twinkle? The answer is the planets actually do twinkle. In fact, everything outside our atmosphere, anything we're looking at outside our atmosphere, does twinkle due to the effect that we discussed. However, we can't notice the twinkling effect of the planet because planets appear bigger in size to us. So let's go to a different screen. So here is the star. A star pretty much looks like a dot in the sky. But if you were to look at a planet actually appears much bigger in the sky. That's because the planets are much closer to us. Now, although we can't see that with our naked eyes, if we were to use a telescope and look at them, then stars would still look like a dot. But planets, well, we can actually make out their shape. If we were looking at a Saturn, we could actually see the rings of the Saturn and so on. So because planets are much bigger in the sky compared to the stars, we can assume that planets are made up of many such dots. So stars are just single dots, but we can assume that planets are made up of many such dots. And so each of this dot will twinkle just like a star, But because we have many dots, when one of these dots become dim, some other dot will become bright. When that dot becomes dim, some other dot becomes bright. And as a result, when we look at the planet as a whole, the overall brightness doesn't change much or doesn't fluctuate much. We can now actually see this effect in action. I have copied this twinkling dot and pasted it over here several times. So each of these dots are going to twinkle the same way, pretty much the same way. Then we'll zoom out and we'll look at them. All right, so let's play the animation. If you see carefully, you can actually note that all these dots are twinkling the same amount because I've copy pasted them. But now let's zoom out until both of this, the planet and the star, pretty much look like a dot. And you can pretty much see that the brightness of the planet remains almost a constant. That's because on an average, the light from the planet pretty much remains the same. And that's why we can't make out the twinkling effect. Now, if you find it hard to see this on your mobile screen or something, then what we'll do is we'll zoom in a little bit, and you can move away from the screen until both of them look like a dot to you. So move away until the star is barely visible and the planet just looks like a dot. And then you can actually see the twinkling effect of the star, but not of the planet. So to quickly summarize, we learned that the twinkling effect of the star is caused due to the fluctuations of the atmospheric conditions, which make the starlight bend as it moves towards us, and as a result, the brightness of the star keeps changing. And this means everything that is outside our atmosphere will twinkle, but because planets have a bigger size, that twinkling effect cannot be made out with our eyes. And for the same reason, the sun and the moon also don't seem to twinkle for us. And this twinkling effect is pretty annoying for astronomers who use their telescope and try to take the photographs of our planets or the galaxies, because the photos don't come out very crisp. And it's for that reason we built the Hubble Space Telescope. The idea was to build a telescope and make sure that it orbits around the Earth outside our atmosphere. Then it will not be affected by the twinkling effect. And as a result, the photographs produced by the Hubble Space Telescope is unaffected by the atmospheric fluctuations, and that's why these photographs are extremely crisp and extremely useful for scientific research.